about LLMs not being all we need, which is shocked to me. I figured that's all we needed.
Thank you.
Thanks, Tony.
So I'm recording this. I'm going to upload it to YouTube so anyone on the witness prevention program or whatever can sort of discreetly move out of the image. So thanks a lot. So this is a part 2. I'm not sure whether part 1 was so great that Chris invited me back or whether it was because the fact that a speaker dropped out and he thought, well, Tony loves the sound of his own voice, so he'll fill in at short notice. So this is LLMs Aren't All You Need part 2. If you weren't there for part 1, don't worry, I'll give a very, very quick recap, okay? So basically, very, very quickly, who am I? So I'm a senior principal architect at Red Hat. I build stuff, I build cloud stuff, I build AI infrastructure. Those of you who hit in this room on Thursday night for the Ansible session, we build a lot of stuff with Ansible as well. So really, I'm cloud automation specialist and increasingly AI. XC programmer. I'm still learning. I think a lot of us are still learning about AI. There's just so much to learn. New papers come out every day. New GPUs come out, maybe not every week, but there's just so much going on out there. Without further ado, I'm just going to try and rush through the first stuff. But who's this for? Who are you and who is this for? Because this isn't really aimed at practitioners down at the bottom. And this slide is from the original LLMs Aren't All You Need. And if you remember it, if you were there, it was the Monday after the OpenAI shake-up, where OpenAI had 4 CEOs in the space of about a week. So that's why they're down here. But we're not really aiming at the machine learning engineers, the data scientists. I'm actually very offended that my friend Stephen didn't come because he's actually writing the libraries which go on down here. And he only lives 5 miles away, but he made an excuse. He's going to be here in a couple of months. Okay, and he's going to talk about optimizing tensor arithmetic in PyTorch and mapping the NVIDIA and the CUDA against AMD, Radeon, and Instincts using ROCm. So if you really like the low-level stuff and you like tensor arithmetic and sparse matrix multipliers and gradient descents, come to that session because you're not going to get it tonight. So I'm really kind of focusing a little bit on MLOps, but really on the AI architects. This is a relatively new expression. I'm going to the big AI engineering conference, and this is a term which has really come into being, I would say, in the last 6 or 8 months. So we talk a lot about data scientists, people worrying about neural networks. My level of neural networks is pretty much in here. You know, I have neural networks for babies. It doesn't even have back propagation in it, but it's a good primer. But this guy has really been on the cutting edge of LLMs and machine learning and deep learning. But what he's really acknowledged, you don't have to read all that, is we're seeing the emergence of a huge group of AI engineers working at a relatively high level, working with the lang chains, the llama indexes, and the haystacks, and making business applications using business data and delivering value to businesses. And as he says, there's going to be a whole group of people who build useful applications for businesses who really have never trained a model in their life. And maybe they've never fine-tuned a model in their life. And we're going to come back to that whole topic because we're going to talk about where does it make sense to train your own model? When does it make sense to take somebody else's model and fine-tune it? And then when does it make sense to use other? And maybe you use the whole thing. Maybe if you are Bloomberg, you train your own model, you fine-tune your own model, you use Retrieval-Augmented Generation, we'll come to that, and you use agentification. You use all 4 of them and you combine them to deliver value to the business. So what happened in part 1? So we talked about LLMs. LLMs have problems. Who's had a hallucination? Right, okay. I don't mean on the 20th of April with the rest of CU. I mean, okay. So we see hallucinations all the time. I actually thought I would summarize this. So I fed the subtitles. There's a Python library which will just pull down the subtitles, and I piped it straight into Llama 2 and Mistral, and it totally got wrong what the first session was about. So LLMs by themselves, they can hallucinate. You can reduce that. Good prompting goes a long way. They typically lack deep domain expertise. Now that's not necessarily true. The best named LLM, so did anyone see the new legal LLM that was released about in the last 2 weeks? And what was it called? Do you know what it's called? No, the new LLM for the legal industry, which is being built from the ground up, it's called Sol. It's the best named LLM. You better call Sol. So that is such a good name. But generally, LLMs lack domain expertise. They tend to be more general. And yes, we are seeing legal LLMs. And by the way, some people have been in trouble. You probably heard that various lawyers have got in trouble in court for quoting case law which didn't actually exist, which they've got off a general purpose LLM like GPT-4, which has hallucinated about some case. They presented it to the judge, and it's turned out that this never actually happened.
No, it's those of us who are actually feeding bogus case law to those LLMs.
Right. So for most businesses, and this is also true of personal AI, so you follow Bill Gates at all, he's very, very optimistic about personal AIs. So here we are in Boulder, a personal AI could be, it could be catered for your healthy lifestyle, you like to ski, maybe you like to rock climb, you like to mountain bike, etc. But let's talk about businesses. They typically don't understand your products. They don't have deep knowledge about their products. They probably do have some awareness of Coke. I'm Coca-Cola Coke, by the way. They typically don't understand your domain in any great depth. They may have a general idea of the sphere in which you work, but for example, here we are in Rule 4. They probably don't have a deep understanding of general LLM, and I mean GPT-4, Claude 3, which is doing really well, the big open source, and I come from Red Hat. What I'm not an expert is in how open source relates to LLMs, because it's quite a complex question. Does it include the data? Includes the weights? Does it include this? Does it include that? But we see with Mistral in particular, Llama's grabbing a lot of limelight, but Llama's probably not as open, as I say, I'm not a lawyer, as Mistral is. So they don't understand your products, they don't understand your domain, they typically don't understand your customers, and they don't understand your market, typically. So that's a challenge if you're a business. If you can use, my daughter can use ChatGPT to summarize George Orwell's 1984 in 3 paragraphs at the level of a very intelligent sophomore. She added the very intelligent. But that's not really a revenue-generating exercise for many businesses. But they are good. They're very, very good at natural language processing. So this is part 2. How are we going to get our data into these LLMs? Okay? Turns out I'm going to say there's 4 ways. Any data scientists in the room before I go out on a limb? Okay, I'm going to say there's 4 ways. There's more than 4 ways, but these are a coarse generalization. You can train your own LLM from scratch, and we're going to look at that. You can train your own LLM from scratch, and there's pros and cons, and we can talk about those. You could take somebody else's LLM or your own LLM and fine-tune it. Okay? And so some of you have seen me present several times because I recognize you, and I've been here a lot. And I don't normally do commercial breaks, but I'm going to do a commercial break today. Netflix is starting at Prime has started it. So this is actually one thing that Red Hat's really, really good at because we do hybrid cloud Kubernetes or OpenShift. So we can do it on-prem, keep your data private. We can do it in the cloud, or you can rent it by the hour from Amazon or Azure. And that gives you a lot of flexibility, particularly if you're in this space, training your LLM or fine-tuning your LLM. Then you can do RAG, Retrieval-Augmented Generation, and we'll talk about that at some length. It's the biggest chunk of tonight. And then we'll also talk about agentification and tools. And right now, the market loves RAG. It's kind of like it's all over. And we're going to see that it's really easy to do RAG. It's really, really easy to RAG and get an average result. You get a result. It's actually hard to do RAG and get an excellent result. That's going to be one of the themes for this evening. So we're talking about getting your data into an LLM. Let's do a simple person's. This is a very high-level overview. What is an LLM? And actually, I'm going to publish this, so it'll be shared out with you. So this presentation by Andrea Karpathy from X of OpenAI and X of Tesla. He does a really good job, but he spends about an hour. So what's inside a typical LLM? You download a GGUF file, for example, with Mistral in it. What are you getting? You're getting a vocabulary. I'm talking about a generative AI doing text. I'm not talking about DALL-E or Midjourney. You get a vocabulary. So here's a vocabulary. It's got a primary key and ID. You've got cat, and you've got a vector. A massive array up to maybe 4,096, depending on the model. A bunch of 16-bit floats. That's what your model will look like when you start with. Maybe bfloat 16 from Google. They actually have special floating point numbers which are widely used in LLMs. Now, some of you, who's downloaded Olama? Okay. Who's downloaded LM Studio? Okay. So you're quite often, you're going to use quantized LLMs. And then basically it means that these big floating point 16-bit numbers, because quite often there's 7 billion of them, or there's 22 billion of them, or there's 70 billion of them, or if you're on GPT-4, there's 1.7 trillion of them. So to shrink them, they crush them down into ints. They quantize them into ints, 7-bit, 6-bit, 7-bit, 8-bit, and now they're pushing it down. And this was a paper which came out a couple of weeks ago about saying the era of the 1-bit LLM. It doesn't make sense to me either. It's actually, I haven't read the paper, but I read the abstract. It's 1.5 bits. But one of the interesting things is, unlike high-performance computing and looking for oil, weather modeling, when you lose the precision in an LLM for inference, in other words, answering questions, doing generative AI, you don't get a massive loss in accuracy at first. So you can go from 16-bit floats down to, say, 7-bit ints, and you see you get very, very good results. So you've got your tokens. You've got your 500 lines of C or C++ or Rust. You've got effectively your executable, which defines your neural network. It's not a lot. It's not millions and millions of lines of code. And you've got your parameters. We'll look at your parameters in a moment. And these things run on top of libraries, okay? So I'm afraid, I really wish Stephen had turned up. You were meant to turn up, Stephen, but you didn't, because he works in this space. So we have libraries like PyTorch and TensorFlow. They sit on top of libraries from the hardware vendors. So the obvious one is NVIDIA with CUDA, which is arguably far and away the most mature stack for things like doing linear algebra. And then underneath them sit the GPUs, Blackwell, H100s, A100s. And if Stephen was here, I would give a plug for the Instinct 300 from AMD. This thing, by the way, is a 128 gig laptop just so that it can run models. And it has neural engines, and it also has libraries. So their library here is Metal. And if you use LM Studio, it's actually in your face, because when you bring up the models in LM Studio, you can choose how to load things onto your GPUs, etc. Okay, now what about the parameters? Well, the parameters are the weights, biases. I finished this just before I left the house, so I'm sorry if it looks a bit rough. It's a very, very simple neural network. And I haven't even had time to say this is the input there, this is the output there. But basically the parameters, when you bring up a neural network for the first time, it's full of these neurons. And they're all linked. So everything in layer 1, hidden layer 1, is linked to everything in layer 2. Everything in layer 2 is linked to layer 3. And every single one of these comes up with a random weight. And every single one of these comes up with a random bias. And if Stephen was here, he would be able to tell you what activation function that he would choose if you were going to say, is this a dog or is this a cat? And then you throw your data through it, you get your result. In fact, we should have one neuron if we're doing cats. No, we can have 2 neurons for cats and dogs. And then you run it against your test data, and then backpropagation adjusts all your weights and biases. And then when they're all right, or they're giving you the results you want, you have your model. You have your parameters, you have your code, you have your vocabulary. And bear in mind, this is a gross simplification. So this is not my world. I don't sit down in the world of training. My code sits many layers above, and I'm very happy about that because I was very poor at math. Okay, so what do those vectors store? So what are these vectors? So I've got a vector for cat, and I've got a vector for dog, and the LLMs can calculate their similarity, and then they can predict. So when I say the cat and my favorite pets are my cat and my dog is very, very likely. Kubernetes is very unlikely, as is, I should put a label on that, as is yacht. Okay, but Stephen will take over for this section. We're going to focus on getting data into our LLM. We're a business, and we want to get data that we can use into our LLM. I'm not going to read this to you. Training your LLM from scratch. Who would do this? You need a lot of things. You need data. Okay, you need a lot of data, typically. You need a very scarce resource. What is the scarcest resource in training an LLM? H100. Sorry? H100. H100. Yes, so the lead times on the H100 are something between 38 and 52 weeks at the moment. It's a GPU. But I would argue that most businesses... So I think the H100 is absolutely valid answer, but I was actually looking for... The first thing is you're going to need real hardcore data scientists. Sometimes you hear people say, oh, the math in AI is actually quite simple high school math, or you pick up a book and it says, you only need high school math. If you're training an LLM from scratch, you do need more than high school math. And in fact, Andrew Nee, who, maybe I'm pronouncing his surname correctly, I'm very bad at pronunciation because of my hearing, he says that if you want to be good at MLOps, you need at least a master's. If you want to be good at training an LLM, you must have it. You know, a PhD is an entry-level qualification there. So you need data scientists. You need H100s or whatever, or analog. You know, you do need these things, and they're hard to get. They're really hard to get, and they're really, really expensive. I was looking at some AWS models the other day. They were $96 an hour. And we can't always get them. If we just try and grab them opportunistically, we can't get them. Sometimes they're just not there. And as I say, the lead time, my ex-boss is the general manager and vice president of AI at NVIDIA. They're backlogged out so far. And I imagine AMD are also backlogged out with the instincts. You know, they're considered. But without reading through all these, so you need all these things, and you need data, and you need the data in a form that you can use for training, and you need test data. So Rick here is a big fan of tests. I mean, if you shove all this data in and then you get some weights and biases, how did you know it's any good? So you're going to actually have to maybe take 10% of this huge training set, and you're actually really going to have to say that is actually a cat or a dog. And there's probably not that many people doing something as simple as that. So training your LLMs, who's doing this? Bloomberg. So outside of big tech and big AI, companies like Bloomberg are doing it, and they're a natural. They have vast amounts of data. Their core business is data. They sell services based on data, and they have vast amounts of data scientists. So they are a natural to create an LLM, and also they're kind of dominant in their market space. I have a friend who's in a not too distant related industry, and we swap messages, and I can tell, he hasn't told me what he's doing recently, but I can tell from his messages that they're much more interested in training LLMs, and they are huge as well, and they have vast amounts of data. So if you do have all these things, then training an LLM may be for you. But it's not for everyone. It's not going to be that every business, and particularly when you start getting into the medium-sized businesses, are going to start training their own LLM. They can't afford to, they can't hire the people, they can't get the GPUs, and maybe it isn't the right. Maybe it's not part of their core business and their core competency. So if they don't do that, what can they do? Well, they could take Sol, if they're a very large group of lawyers, or they could take another LLM which pre-exists, or it could be their LLM, and they could fine-tune it. So in other words, they lay their data on top of it. They need less data, they need less data scientists, they need less GPUs, and this can be an ongoing process. So for example, in fraud detection, if you're doing fraud detection, you don't just train the model once or fine-tune the model once. You're laying more and more data on it over and over again, and you're keeping it current and up to date so it will recognize new patterns. So these two are very, very valid, and this is actually, I'm actually presenting technologies where, not really Red Hat's focus. These are our focus. We build infrastructure to do this on-prem and off-prem with OpenShift AI. And you can run Kubeflow, and you can train your models, you can do fine-tuning, and you can do LLM. But I want to leave these two behind and make it more accessible to us. Things that we can do. You can go home and do this. I mean, you can go home and do this. It's only like 40, 50 lines of code to get started. Your results might not be very good, but they'll get better. So before we do that, I want to talk about key context. Context windows. It's really interesting. When ChatGPT 3 came out, and it was 3 and 3.5, which I think ignited the revolution. So the thing that ignited the revolution was a paper called Attention is All You Need. And then came along, GPT-3, GPT-3.5, and people were like really wowed by them. Well, they actually had really small context windows, and context windows are what you throw at the LLM. Give me a book review of George Orwell's 1984 in 3 paragraphs at the level of a very smart sophomore. And that goes into the context window. You might say it goes into the prompt, but it's what you're throwing at the LLM. And then Claude 2, which has had very, very good results, and it was a lovely LLM to use. I used to talk to Claude 2 and ChatGPT 3.5. Sounds very sad, but I did. And Claude 2 was very, very good, and so was Pi. So Claude 2 then came up with a 100K context window. These are tokens, by the way. 100K tokens is roughly 70,000 words. Cat is a word. Run is a word. Typically, running is not a word. So something like Claude GPT, running is not a token, sorry. Running would be broken up. You could actually train your vocabulary to have the word running in it. But So if you see 100K context window, you've got 70 that's tokens, you've got 70,000 words. GPT-4 comes out, they upped it to 120K. A couple of weeks later, Anthropic bumped theirs to 200K. Claude 3 also supports 200K. And then Gemini just came out, 1.5, and they support 1 million tokens. That's a lot of words. And then Google have actually tested. So Google, Gemini is from them, the successor to Bard. By the way, Google has the worst hallucination rates in the world. I'm not saying Gemini has, but Bard had some stunning, they have benchmarks for hallucinating. And Google's right up there as the champions, but they're pushing up to 10 million tokens. So this is quite interesting, because that means that you can take your data about your business, about your customers, that report that you license from Gartner Group with the rights to put it in, hopefully, and you can shove it in and say, using this, answer my question. So context windows are very, very key, because they allow you to add data to your large language model on the fly when you ask a question. And we got some code. So I'm using LangChain because LangChain is probably the most popular framework in the space of AI applications. So we mentioned PyTorch and NumPy and then CUDA's down there. So LangChain, Llama Index, and Haystack are right up at the top. They give huge abstractions. You can connect to an LLM in one line of code, and you can you can literally write an application querying an LLM and a RAG system in, without the imports, probably less than 20 lines of code. So with a context window, so what we care about is line 6. So what we're doing here, actually, from lines 4 onwards to lines 4 to 7, we're doing prompt engineering. This is this fabled career where they're going to pay you $450,000 even though you don't have a degree, because you become a prompt engineer.
What would you say the floor in memory would be for like a laptop to like mess around with LangChain?
Okay, that's a great question. So you know how we were talking about quantized models? So it's actually not that prohibitive. So it's really interesting. So let me just clear the screen and let me just make this a bit bigger. So these are quantized models. In other words, those 32-bit floats, so they're probably typically 7 billion parameter models, but those 7 billion floating points have become 7 billion 6 or 7-bit integers. So at Red Hat, we like Merlinite, which is derived. I like Mistral a lot. So Mistral is 4 gig. So when you run it on your, we'll actually run one. So I'll get back to the slides, but I'll start one up. This is LM Studio, and then you can actually see one running, and we'll see how much space it takes. So as a Brit, I like anyone called the bloke. I don't know whether he's bloke, but he's very big. He does a lot of quantized models. Okay, so it's loading it. It's loading. This is a 7 billion parameter model. You can see the RAM usage. I don't know, you can see at the back is we're 3.8, 4.6. My machine is 128 gig. I know that's not normal for a laptop, but it was built, I bought it. Okay. Okay. So this one is taking 7 gig of memory. So you're, sorry?
Do you have any of it offloaded onto a GPU?
Well, so, okay, so this is an interesting digression. So Macs are really popular for AI developers running around who want to do stuff locally on their laptop. They have unified memory, okay? So what unified memory means is They actually have GPUs and neural engines, so they have dedicated silicon for both, and they can access the entire memory space. So I can actually run a 70 billion parameter model on my laptop. And I'm sure, Diane, you can confirm a 70 billion.
It's 140 gigabytes typically of GPU memory that you need to use.
Well, so if you're using floating point 16, but we get good results out of int, you know, down at 7 or 8 ints.
Yeah, I'm talking FP16.
Sorry?
FP16.
Yes, yes.
About 140 gigabytes
Right.
of GPU memory, which means for me 2 H100s.
Okay, so it means that you basically multiply the parameters by twice. But I would say if you want to run LangChain on your laptop with a local LLM, you could choose to run a quantized version of Mistral at 4, 6, or 8 gigabytes, and your application. And then when you're ready to go to a serious level, in LangChain in a single line, you can flip from your local LLM to a remote LLM running on multiple H100s. The second, so what you trade off in the Mac is memory bandwidth. I've got 400 gigabytes a second. Stephen, who's not here, he has 5.6 terabytes a second, but he's now dwarfed by the new Blackwell, and I can't remember the memory bandwidth of the Blackwell. But he has 196 gigabytes of high bandwidth memory 3. But you can make it work on a 16. If you've got a 32, you could do local development. We'll run a RAG application, an LLM, on my laptop in a minute, and admittedly it is highly spec'd. So this, by the way, is LM Studio. LM Studio is nice. I tend to use a Llama because it's just a single command and I'm a CLI person. Yeah, so basically, just a quick digression, context window. So in my system message, I am telling my LLM who they are. I'm giving them their persona. I can put a whole bunch of stuff in there. I can do one-shot prompting or multi-shot prompting, where I actually give it examples of the questions I'm going to answer and give it examples of how it's going to answer me back so that it picks up a pattern. And the LangChain examples will use music like Taylor Swift, and the model says back to them, you know, Taylor Swift's released this and such, and this particular genre. But this is the important thing. The human message is typically the question, if you think of a chat client, where the question and the context, and this is what we can pull out of our RAG-based systems or agentification, and then we just fire these things called chains, and anyone who's done Linux pipelines will recognize this, where we send the context to our RAG systems, our vector databases, and our questions, pass it to the prompt, and we send it to the model, the LLM, which could be on your laptop or could be remote, and then we get an answer. So context windows are key. They allow us to pass data into the LLM, which it doesn't already have. So with fine-tuning, you're baking the data in. And I missed out one very important point in fine-tuning. How many people work with databases? Okay. How many people are familiar with the term CRUD? Okay. So, database. I can create, I can retrieve, I can update, and I can destroy. Yep. And we take that for granted. So when Mongo came along, we probably didn't know what document databases were, or when graph databases came along, but we knew how CRUD worked. If I stick the price of this, if I fine-tune the price of this DJI Mic 2 into my model, it's not going to be easy for me to change that price, and it's not going to be easy for me to delete it, because basically when you're layering those layers on and fine-tuning, they're not CRUD operations. You're giving this knowledge about something. So there are some things that should not live in the model. Some things should absolutely live outside the model. They don't make sense. LLMs are very good at this. they're not necessarily very good at that. So if you've got something which is dynamic, or let's just say NVIDIA's stock price every hour, do you really want to bake that in, or would you be better off looking it up? So we'll come back to that in a second. Okay, so hopefully you trust me now that we can put data in. And now, if you remember my little diagram here, it went RAG and agents, and that's typically how people look at it. Train, fine-tune, RAG, agents. But I want to deal with agents before RAG, because RAG is the big one. So agents are really interesting, and I'm going to use lang chain terminology. Agents are when you empower your application to do what I was just talking about. So let's just say math. If you ask ChatGPT, what's 2 and 2? It will say 4. If you say, what is the square of 4? It'll say 16. If you ask what the square root of 9 is, it'll say 3. It's seen that in its training. And I haven't tried it recently, but if you go to the earlier versions of ChatGPT, like 3, and you say, what's 65,432 times 200, whatever, it gets it wrong. It's never seen it in training. And it doesn't know how to do math. And you could spend all this resource getting data scientists teaching it how to do math, but you don't need to do that because we have calculators, and that's what agents do. Agents identify things that are better done outside the LLM, and hard math or easy math is better done outside the LLM. You just call an agent. Agent, call BC. Who used BC? Okay. You know, it could be BC, it could be Excel, it could be an application which is bespoke, designed to do the sort of math that you care about. Another thing, so newspapers. Let's just say Freddie, the financial influencer, dies this evening at 6 o'clock, unfortunately, and the Wall Street Journal needs an obituary. They already have an obituary. He's famous enough, but it's not complete. Now, you could train your LLM on that, and you could fine-tune everything about it. But what you can do is you can take what you have, and then you can use agents, and agents will go out and they will call. They will call Wikipedia. They will call search APIs. They might call APIs and say, when did he last present? Who did he work for? What controversies was he involved in? And then they can package all that and throw it at the LLM. So some things are much better left outside of the LLM. Don't train it in. Enable the LLM to use tools. And let me see. I'm going to see whether I think I've got a lang chain. Yeah. Here we go. So I'm using lang chain because it's the biggest of the AI frameworks. But here, for example, an agent allows an AI application to select a tool. So it could use Bing Search, for example. It can use Wikipedia lookup, and then it just takes that, packages up the data, and it throws it into the LLM, perhaps along with a lot of other stuff. So another, sorry?
Throws it in as the context.
It puts it into the context window. And the prompt engineers can kind of wrap all that. So you can have huge prompts. So that prompt was 2 lines long. You could have prompts which are hundreds of lines long. So you can say, Freddie's romantic liaisons, Freddie's controversies, Freddie's presentations, Freddie's employment. I'm using Freddie because my wife said, if I said Justin died, or I'm not going to say any other names, people, I didn't want to use an identifiable name. Okay, so, but anyway, you can insert whoever you no longer wish to be on the planet as your. So that's what agents do. And I think there's been a huge amount of hype about RAG. Now there's going to be a huge amount of hype about agents. So let's get to RAG, Retrieval-Augmented Generation.
Yeah, just a question on how the agents are baked in. So you're saying in the context window, would the idea being like, if you give me a math calculation, use this tool to do it?
Yeah, so they can actually even use LLMs to do it. So one of the reasons why LangChain, for example, is called LangChain is, so, you know, we often think an AI application like a chat application does a few things and calls an LLM. But now they're going LLM, LLM, and they're going backwards and forwards like this. So for example, they say, hey, LLM, I got all these answers from my RAG system, for example. I've got these 5 answers. Could you rank them for me? Because my vector database said this one was the best answer, but I want your opinion. And it says the third one's the best answer. And then you redo your prompt and you throw it at another LLM. Could be the same one or a different one. So you can actually use LLMs, but in LangChain, you have the concept of making these chains with agents, and the agents will do the tool orchestration for you. So that sounds a bit untangible, I think. So if we go back a bit, you see this thing here? These can be huge. And not only can be huge, you can have chains of chains of chains. So you can make 5 chains. So one chain can be talking to loads of agents and LLMs and RAG systems, and another chain can be doing something else, and another chain can call both those chains and chain them together. They're exactly like Unix and Linux pipes. So basically, what goes in here can be consumed by the probe. It's like standard in, and what comes out on standard out from the prompt can go straight into the model, and what comes out of the model can come straight into an output parser. An output parser is just something that prettifies your output. Let's just say your LLM doesn't respond in JSON and you want it to respond in JSON. You can get your output parser to convert it to JSON or do styling, okay? So, so the AI applications will orchestrate the agents, and the agents will, so here, you see, agents make the decisions and tools have the functional capability. So it's a separation of concerns. I wouldn't say it's like microservices, but it's a separation of concerns. So somebody could just write tools. I'm going to look up a stock price. I'm going to get it from Bloomberg. And somebody else would write an agent which would select that tool when it was NASDAQ.
So the agent isn't embedded into the LLM, rather it's taking the results of an LLM?
No, it's not embedded in. It's way outside.
Okay.
It's all, yeah. No, that's a good question. It's a great question. No, it's orchestrated by the application.
Right.
So
you have something that like do this complex thing to the LLM, and some of it was math, though it knows to pass that to the agent.
yeah.
Or?
Let me hang on. Hey, let me go and find, here's one. So this is just a tool, It's that easy. It's that easy. So Tavily is one of the big tools. You need an API key, but it will do a lookup. It will do a search on the internet for you. So your prompt says, okay, if so-and-so is dead, go and see whether they've got a Wikipedia page. And the agent would say, ooh, actually the agent wouldn't choose Tavily because there's actually a Wikipedia one. In fact, if we go here, if we go here and we click on tools, where's my mouse gone? There it is. Stop running away. Oh. If we go here, and we zoom it down, these are pre-baked agents. You can write your own. LangChain have done a really nice job of documenting how to write an agent, how to write a chain component, how to write this. I'm just using LangChain. Maybe you love Llama Index, or if you're looking around, LangChain's #1 at the moment in this space. But you can see, let's say we're talking about Wikipedia. Absolutely. So-and-so's died, is celebrity or famous for whatever reason. An agent could say, oh, I'm going to use Wikipedia, and I'm going to put together a query, if you remember, so that would be engineered in. could you go and fetch so-and-so's Wikipedia page and pull it down? And then you could then pass it to another LLM, which would take all these stuff from all these agents and RAG systems, put them all together, and maybe throw it at, let's just say ChatGPT, for example, and then say, could you write me an obituary? Or could you give me a start? Everything in this space is changing, by the way. I mean, LangChain is, for example, I have colleagues at Red Hat, so quite a few of us actually use LangChain, including in our OpenShift AI team. And the common complaint is the APIs change every week. They change and they change and they change. So, RAG, Retrieval-Augmented Generation, what is it? We're going to use the chatbot. This could be a dashboard. It doesn't have to be a chatbot. You ask it a question. Okay? You ask it a question, and let's say we're a business, so what is the forecast for ruggedized IoT devices in the Middle East region for the next 2 or 3 years? Because that's your core business. You're Acme IoT. You make ruggedized IoT, and you put vast amount of your product data, your customer data, analysis, market reports, Gartner, Forrester, whoever your analysts are, into your RAG-based systems. They will do a similarity search, and they will retrieve all the chunks, and we're going to get to those chunks in a minute. They will get them, and they will get the best ones, and then they will pass it to the model, and the model will write the report. But the model doesn't have to know your products, your devices, or your market. Remember, we have 60, 70, 80,000, 100,000 words to play with, and we can pass it in. And when I say we've got 100,000 words to play with, there is a phenomenon known as lost in the middle. And if you give your LLM 100,000 words, a lot of them are biased to the last words. People are working on that. So RAG is these are all videos on YouTube, and there are hundreds of them. And I salute anybody who takes the time to create a Git repo, to create a 1-hour video where they talk through Jupyter notebooks to go with it. But one of the things you'll see is RAG is easy to get a result. It's not necessarily easy to get a good result, which is probably very much the same for fine-tuning and for LLMs. So we've got data. You've got RAG, you've got all this data. You're a company. Any data people, any ETL people, decision support people? Nobody? Okay.
I did a little while I was at food.
Okay, is that why you moved into containers?
Yes, it was much easier.
Okay. Okay, I actually tried to convince an ETL person to come along, one of my neighbors. I thought he could add some color to this. Although he's not in AI, he's in ETL, extract, transform, load. So you've got lots of data. And you want to get it into your systems. You've got your LLM, you can train your LLM, you can fine-tune your LLM, you put it in your RAG-based system. So let's say you're going to put it in your RAG-based system. What are you going to do? You feed it into chunkers. You feed it into chunking algorithms. And the most crude ones of these literally do that. They literally chop it up as it comes in. So you take an abstract, a scientific abstract, or a report on ruggedized IoT devices in the Middle East, and it will take a bunch of bytes and turn them into a vector. And it will take a bunch of bytes and turn them into a vector, and take a bunch of bytes and return them into a vector. And you'll get a result. It's a bit like the very first time you did Hello World. You will get a result. In fact, let's get a result. Let's get a result. Okay. Hopefully these two haven't gone to sleep. And as I said, everyone's writing RAG apps. So here are my RAG apps. Okay, so on the left, I have an LLM. I'm talking to Mistral. And I'm going to choose a Red Hat product because we've been talking about it. So I'm going to say, what is Red Hat? And I'm going to capitalize it, ODS. So internally, we used to say ODS, Open Data Science. Now we say, well, we talk more about OpenAI. So I ask it, what is Red Hat ODS? So it doesn't have a meaning. Talking to Mistral, the same, exactly the same instance running on the same API. What is Red Hat? This would be very embarrassing. We were talking at the table earlier about live demos. So I know there's a few Red Hatters in the room, but I will answer for them. That looks pretty good. I had some great hallucinations from ChatGPT, man. I had some real hallucinations. It made up a Red Hat product, and it was so credible. It was so credible. It explained what Red Hat ODS stood for. There was some open data standard, and it made up this complete fabrication. I actually sent the screenshots because I'm working with some people in the OpenShift AI BU, and it was so credible. It was very frightening how credible it was. But this is RAG in action. So this is exactly the same LLM, okay? And all I have done is the simplest query in the world. And if anybody thinks I've done something super fancy, I have not. Let's just... I'll make this bigger. Yeah, I've just said, answer the question, blah, blah, giving priority to the following context if it was via context. And this context comes from a retriever. And all the retriever has done is it's taken my question, what is Red Hat ODS? What is Red Hat ODS? And it has converted it into a vector. Okay, and the embeddings, those chunks are stored in the exact same style of vector, the same algorithms, the same length, and they do similarity searches. Okay, and I can then just say, give me the top 5. And then it will take the top one and throw it at the database. So getting a result is easy. But when you start putting lots of data in, you suddenly find you're not getting the result you wanted. So.
Can you go back to the previous screen?
Sorry?
The previous screen?
Oh, yeah.
Yeah, the previous screen.
You want?
Yeah.
I'll get it back for you. I'm slightly deaf, so I'm going to have to come back over to you.
I should have spoken up. So essentially what my question is, that's the chain for the RAG that you're doing.
That's a very simple chain, yeah.
So where in that chain are you doing the citation?
Oh, so I get that for free. Okay, so, and you wouldn't always get it for free. So what's happening is, so the retriever here, retriever is doc search as retriever. So it's connected to a vector database, okay? It could be, in this case, it's Chroma, which is like, it's the SQLite of vector databases. You know, it really is. But it's not just returning the text. It's returning metadata about the text. And I've actually been working with a friend of mine. He's been working really, really hard on getting good metadata and good chunks. So that citation is coming from that. And that's actually, it's really good that you've touched on that point, because although GPT-4 is starting to give some citations, citation is an advantage of RAG-based systems. Imagine I decide not to give Rick a loan. You know, he comes to me for a loan, and I say, no, you can't have a loan. My LLM says you can't have a loan. And Rick says, that's because That's
I
because
stole the last one. I didn't prepay the last one.
that's because he's in, whatever reason, an LLM, and this is really important for insurance companies. An LLM we often don't know why LLMs give the answer they do. Now, if you use RAG-based systems, complementing, so you have the LLM, so by all means, train your LLM and do your fine-tuning. But with RAG-based systems, you get very, very good attribution and citation. And not only that, they are CRUD. So if you decide that a policy is there's discrimination in all the LLMs. There really is. I mean, it's just a fact of life. We can't help it. If we all go away and decide to do an LLM together, it will have our grouped biases reflected to some degree. We'll have a hard time engineering that out. But when you move up a level and you're pushing data in, which is CRUD data and has metadata attached to it, and you can see which records you pulled, then you can do very accurate citation and say, the reason why we came to that decision is because this document says, don't do this. It's not like, well, the LLM said. You actually have a point of reference. So it's actually a very useful question. And Chainlit, the interface I use, it gives you so much stuff for free, like you don't even have, I mean, there's 60 lines of code, this RAGBot. The LLM one's about 40. I'm not saying they're good, because they're not good. There's a lot of bad practices in here. This is just a basic one.
So is everything that you're doing here local?
Absolutely, yeah.
So the vector database is local.
Yeah.
All your RAG info is local. Everything is local.
Yeah. So I'm going to get extra credits today, because sometimes in the old days, because I was on a Mac, there were a couple of times when I had to use Docker. But Podman is so good now. It is so good, and it's so secure. Sorry?
Podman desktop.
Yeah.
Now that you have it on your desktop.
And Podman desktop. I don't use the desktop much, but it's gorgeous. And I was here on Thursday, and Natalie was saying how beautiful Podman desktop is. And somebody else who was walking past, wasn't even part of the conversation, went, I'm being recorded, Docker desktop sucks. Yes, Podman desktop doesn't. And I'm very conscious of your time, but that's Podman desktop. But anyway, yeah, so I'm going to get you my run command. So if I go podman run, just so you can see what's going on. I'll just retrieve my run command. I'll make it bigger. And basically, so here's my podman run. They've got a bunch of ports. So the two chatbots are running on ports, and I just put them in iframes, which is why you can see them side by side. But the important thing is here, -e llama base URL equals it host docker internal 11434. That means I'm talking to the host operating system. And this is a good point, because if I run a Linux container with an LLM inside it on a Mac, Linux has they're working on this, but Linux has no awareness of Apple's Metal libraries and the neural engines and the GPUs. So therefore, the math runs on the CPU, and CPUs seriously suck at multiplying tensors together. Sparse matrix multiplies, dot product. So they really, really suck. That is why the H100 it's got a 38-week lead time on it, because that's what GPUs do really well. They're not GPUs anymore. They're highly optimized for tensor arithmetic. And that's what Stephen's going to present in a few months. And he knows his stuff, unlike me. Okay, so I'm getting to the end. Lock the doors. Don't let anybody out. So I chunk those things. I chunk them, and then I embedded them. And the problem, and chunking is basically chopping up the document. So they're PDFs. Big mistake. Big mistake. PDF is an awful format. There's really only 3 groups of people who like PDF. We like it for PDF readers because, you know, we can share documents. But how many of you have a Kindle? Has anyone ever tried to read a PDF on a Kindle? Or on a phone? Have you tried to read a PDF on your phone and you're going like this? It's an awful format. It's only of interest to printers and graphic designers and people doing preprint. I have a friend who's a graphic designer. He loves it. He designs food packaging. I think that's very boring. He will tell me that what I'm doing is very boring, so we're quits. But PDF is an awful format because it stores the most ridiculous information, like fonts and where they are. What we care about in data is headings, semantic meaning. When you do a paper, an abstract has meaning. It's the abstract. Let me inflict a terminal on you just for one more second then. No, but seriously. Oops. Okay, let's clear the screen. So, this was my session. Where is it? It's vanished. So I gave this at the Red Hat One conference. This was my lab. So I supported lots of labs, but my own lab was about containerized Ansible automation platform. And there we have a nice hierarchy of stuff, okay? We have nice information, and it's an ASCII doc, okay? So we could do an introduction here. Look, full of headings, lots of semantic value in there, yeah? Well, when I loaded that into a RAG system to chat with my lab, write an AI where you could chat with the lab, it's a project I'm working on. If I do it in PDF, I've lost all that. Now, that was HTML. So if I go and find, let's just use RG, I'll just recall a command. So if I go and get my headers for that module, now we got some semantic value. Oh, we got header 1 is introduction, header 2. But if I go and look at my source material, let's find my source material. Wonderful, wonderful. By going to PDF, I confused everything and told my LLM and my embeddings all about font sizes and the bold and Helvetica New or Red Hat display. But if I go back to ASCII doc, I have this wonderful hierarchy of data. And if I use that, and so think about that. Remember garbage in, garbage out. PDF isn't necessarily garbage in, but it's semantically awful. So don't do it unless you have no other choice. Try and go to the, use the source as the message.
Are there input parsers for PDF?
Sorry?
Are there input parsers for PDF that make the garbage less garbage?
Absolutely, absolutely. That's a great question. So how does chunking occur? There's millions of chunking libraries. I can pass Python through a chunking library and it will find all the Pythons and put them in their own chunks. I can pass Markdown through one of these libraries. LangChain is a library for Markdown, and it will break it up into and understand all the headers. Now, it won't understand ASCII doc, and if any of you know ASCII doc and Python are very close. So a colleague of mine, Guillaume Moussier, who's at Red Hat, he's actually working on an ASCII doc one. ASCII docs is kind of like a better Markdown, in my opinion. I don't want to be controversial. It's just richer. It gives us more control. I'm not having a go. I mean, so chunking. So let's, but keeping with this chunking stuff, hang on. We're almost done. We're almost done. Let's go to ChunkViz. Let's go to ChunkViz and we'll see chunking. So everyone's first chunker is a character splitter. And this is, I put the first 4 paragraphs of this very famous paper called Attention is All You Need. Abstract the dominant S. I'm going to stick that in my vector database. That's not very good, is it? You know, if you're going to say, hey, what was, could you summarize attention is all you need? And it pulls back this chunk. So that's not very good. So what do? We could actually bump this up to 512. No, not 5,000. Chunking libraries typically can't go above, much above 8K, generally. Why will it not get rid of the 1? 100. I can't get rid of that 1. That's really weird. Okay, oh no, now when I reloaded it, I picked up a completely different bit of text. But 512. Okay, so that's slightly better, slightly better. These are better chunks. This is still a character splitter. Don't use a character splitter. A character splitter is day 1. Since you're in day 2, at least use a recursive character splitter, which will suddenly start going down. Ooh, it's spotted 2 new lines. It likes that. So now our chunks are getting better and better and better. So unfortunately, although we don't need the data.
What's a recursive character splitter?
Sorry?
For those of me who are ignorant, what's a recursive character splitter?
So a recursive character splitter, that's a good question. A recursive character splitter goes through and it splits on certain criterion. So it shoots down here and then it's coming back. So, 2 new lines. So this one, and you can program. You can actually tell it what to do. So what this is showing you is it's picking up paragraphs. Now imagine a scientific abstract or something. That paragraphs are a pretty good starting place. But Rick and I were out for beer the other day, and you won't be able to see this. I think I've still got the menu. I've got the menu, okay. So you've all seen a beer menu, okay, so it's full of IPAs. I want IPAs. So I want a chunk on beers. I mean, it's the most natural thing in the world. I want to chunk on beers. Rick doesn't want to chunk on beers because he will talk to the waitstaff for an hour. He'll find out they once went to Val d'Isere, he went to Val d'Isere, and they'll talk about Val d'Isere, and I'll be there waiting for a drink. That's the big problem. But I would want to chunk on beers. I want to take their name, their strength, their price, and their description. I would like those to be in a chunk, and then I'd like to go to the next chunk. So if that was my core business, I would write, and even with my average Python, it would not be hard. It would not be hard to write a semantic chunker. So if you're getting started tomorrow, use a recursive character splitter. Now we're going to wrap up because we're going to do another one of these in a few months. So there's an expression, naive RAG. A lot of the RAG out there is rubbish, including mine. I have a marketing team using my RAG bots, those that you saw. It's not very good. We're making it better. And they use things like character splitting and recursive character splitting. If you are going to use those, use the best possible format. So use the source if you can. Use Markdown. There are JavaScript splitters. There are Python splitters. I mean, not written in Python. Well, they are written in Python, but for Python. Investigate splitting semantically. So then it will go, oh, this is the abstract. This is the introduction, and keep those 3 paragraphs together. This is section 2. There are tools to do that. Try and preserve valuable context. If the title of the document is Attention is All You Need, and that is the title, maybe you want to retain the title in every chunk, including the conclusion, so that there is context that the conclusion maps back, because the semantic search will not necessarily use the metadata. There's a new thing, there's things like agentic chunking, and they are using LLMs to do the chunking. Why not? Why not? Remember, in frameworks like LangChain, you can chain lots of things together, but in any framework, why not ask an LLM to chunk it? And say, hey, could you break this document semantically into, pieces roughly 4,096 characters, but don't get upset if you have to make it a bit bigger or a bit smaller. Now, this guy's got a great 1-hour session. He's got a great 1-hour session, and he's got a whole website which is devoted just to chunking, okay? So master chunking. And then, remember, if you remember what this section was called, it was getting data in to your LLM, not getting it out. So we'll have to do that another night, Chris. But once you've done that, you've got to choose your embedding library. How do you turn it into a vector? 4,096, 364, because that vector has to capture. Imagine putting War and Peace into a vector which was 12 elements long. It would probably do a bad job of it. So you need to think about how you're going to choose your embedding library, and you probably want to either brush up on your linear algebra, read your primer, or chat with your favorite data scientist, because there's a lot of math involved in similarity search. There's lots of algorithms, and if you want to ask somebody after the session, when it's over, ask Rick, don't ask me. Then you've got to choose your vector database. How's it going to store that data? You've got 1 million embeddings. You can't run a vector against 1 million other vectors every time somebody asks a question. So you've got to look at how it's indexed and what approximate nearest neighbor and other algorithms mean and how they're retrieved. So you need to choose your indexing and your storage files. You need to choose your prompts, and when you've got all that, you can start getting into the world of re-ranking, where you get LLMs to help you rewrite your answers. And then you can actually get your LLMs to rewrite the user's query. So there's a whole ton of stuff still to do. This is a good folder. I'm going to share this with you. This has got 6 really good articles on advanced RAG, taking it to the next level rather than my little chatbot and all those videos that you saw. So that was part 2. It's begging a part 3. Maybe somebody else can do it, which is getting the data back out. So try some RAG. It's easy. It might not be good, but it's easy to get your first results. Okay? I got Git repo. Those AI bots are in a repo. I'll share the slides. I'll send the details to you, Chris. And thank you.